In physics, we are going to use trigonometry a lot. And when I say trigonometry, I really mean the trig functions that you learn in geometry: sine, cosine, tangent. You should be able to use these three trig functions to solve for the sides or angles of a triangle with no problem. If you can't, you're going to be stuck a lot. So make sure that we get this figured out. Either come meet with me or we'll do whatever we can. But this is very, very important because this will be just the basic part of a lot of problems, would just be finding the side of a triangle or the angle of a triangle. So to review, make sure you identify where the 90 degrees is located. Then identify which angle you are working with. So in this case, this is our main angle. So in reference to this angle, obviously the side across from 90 degrees is our hypotenuse. From our angle, we look for the opposite, and then the one next to the angle we're working with is our adjacent side. And so then we will base sine, cosine, tangent all off of those. So sine, opposite over hypotenuse; cosine, adjacent over hypotenuse; and tangent, opposite over adjacent. And again, just one more way to look at that. If we're working with this angle, hypotenuse and opposite, we're looking at this, cosine is adjacent over hypotenuse. And if we're looking at this angle, we would have the adjacent and the opposite, that we would use opposite over adjacent for tangent. When we look at this problem, we see it says a sunny day, a tall building casts a shadow of 67.2 meters long. The angle between the sun's rays and the ground is 50 degrees. Determine the height of the building. In physics, it's important to always draw your picture. If you don't draw your picture, especially as we get more complicated problems, you're going to get lost in what you're actually looking for. So we're going to draw our building. And then it casts a shadow. So if the sun was up here, the shadow would be coming down like this. So it says that the building casts a shadow that is 67.2 meters long. So the shadow would be here. So this length is our 67.2 meters. And the angle between the ground and the sun's ray is 50 degrees. We want to know the height of the building. So if we're looking at this side of our triangle compared to the 50 degrees, that's going to be adjacent. And we're looking for the opposite. So we're looking for opposite over adjacent, which is going to be tangent. So tangent of 50 equals opposite, which is what we're looking for, over 67.2 meters. And then we would solve. So we're going to take tangent of 50 times 67.2. When I type that into my calculator, I get that x equals 80.058. So I'm going to say 0.9 meters. So as we look at this next problem, we're driving to St. Louis. I have a lovely car drawn down here for you. You are seeing the Gateway Arch in the distance. So I have our arch drawn over here, and it says the arch is 192 meters tall. You have a line of sight from your car to the top of the arch is approximately 2 degrees with the horizon. So the horizon, we have this straight line at the bottom. We want to know how far are you away from the arch? So if we look at this, we are looking for the distance at the bottom, how far away, and we have opposite 192 from our 2-degree angle. So again, we're going to be working with tangent. So tangent of 2 is going to be opposite, which is 192, over adjacent, which is x. So here we will divide 192 divided by tangent of 2, and I get x equals 5,498 point, make sure that's an 8.16 meters. This next problem, we have a highway to be built between two towns, one which lies 35 kilometers south and 72 kilometers west of the other. What is the shortest length of highway that can be built between the two towns, and what angle would this highway be directed with respect to due west? So first I'm going to draw an axis. So if our first town is the center point, our second town, we're going to make 35 south, and we'll say 35 south here, and then 72 west. So 35 south and 72 west. So the shortest highway would be the hypotenuse of that triangle. So now we can use the Pythagorean theorem to find our hypotenuse. So we'll have 35 squared plus 72 squared equals our hypotenuse squared. So for x, we plug that in, 35 squared plus 72 squared, I get 80.06 kilometers. Then the next part of the question says, at what angle would this highway be directed with respect to due west? So with respect to west, we would be going this way. So to find that angle, we can use any of our sine, cosine, tangent. If we look at the 72 and the 35, we would be using tangent. So we would have tangent of our angle that we are looking for equals opposite would be 72 over 35. So on your calculator, you'll do inverse tangent of 72 over 35. So it would look like tangent inverse on your calculator, 72 over 35. And I get an angle of 64.08 degrees. And that would answer what angle we would need there. So we just used it on that last problem, but make sure you are familiar with and can use Pythagorean theorem, a squared plus b squared equals c squared. And again, if any of these problems seemed confusing to you, make sure that you check in with me and we get this figured out, because this should be second nature for a lot of the problems we will be doing moving forward.